Today I'll be talking a little bit about place value and using it to do some interesting things, including a proof that 0.9 repeating is equal to 1. So let's talk about place value. Place value is one of those things that really made the math that we have today even possible. The idea that you can have a limited set of symbols, in our case 10 of them, and use those to make numbers. Let's start with just a number and look at what it means to use place value to form this number. So here's a number. Now this is the tens place. It means 2 tens. This means 7 sets of 1. This means 4 sets of 1/10, and this means 3 sets of 1/100th. So I could write it as this. 2 times 10 plus 7 times 1 plus 4 times 1/10 plus 3 times 1/100th. Now, let's see what happens if we multiply by 10. You may remember something called the Distributive Property, which says that if we have the sum of a bunch of numbers and we multiply this whole sum times a certain number, we can multiply that number, which in this case is 10, by each individual number inside the sum. So what if we do multiply it by 10? Well, 2 times 10 times 10 plus 7 times 1 times 10 plus 4 times 1/10 times 10 plus 3 times 100th times 10. Okay, so this is 2 times 100 plus 7 times 10. Now for these we have to think about how fractions work. 1/10 just means it's 1 cut into 10 parts that are equal. Take one of those parts. Well, if I've got 10 equal parts of a number and I take 10 of those equal parts, I'm getting that number back. And the number was 1, so that's what I have. 1/10 times 10 is 1. And the same thing happens here. Think of it as the way money works. This 1/100th is like a cent, 1/100th of a dollar, or 1 pence, 1 penny, 100th of a pound if you're using that currency. What's 10 of them? Well, 10 pence, or 10 cents, would be a tenth of a dollar or a tenth of a pound. Therefore, we're here. Now, I took the number from here and I broke it out into a place value form. Well, I can take the place value form that I have down here and put it back into a decimal number form. So that's 274 and 1/10. So you may have learned in school the idea that if you multiply by 10, you push the decimal point to the right by one place. Well, that's why it works, because of place value. Well, that's very well, you say. Well, what else can we do with that? Well, one interesting thing you can do is you can take just some number, arbitrary number, if it's a repeating decimal, and figure out what the fraction form of that is. So let's do this. 0.51 repeating. 0.51 repeating. That's the number I'm talking about. Let's call this x. That's no accident. We're going to do some algebra. So say x is 0.51, repeating. Well, what if I could write this number as 51.51, repeating? How many places did I move the decimal point over to do it? Well, starting here, 2 places. That's like multiplying this thing by 100. We're thinking 100x. The next thing we would do is look at these repeating decimal parts. They're equal. If I take 100x, this number, and take away this number from it, well, what's going to happen? These repeating decimal parts are equal. They're going to cancel out. It's like saying, suppose you did 4.2 minus 1.2, or think $4.20 minus $1.20. It would be $3. The decimal part goes away. It's no different for these repeating ones. So I have this. The decimal parts will cancel, leaving the 51 minus 0, which is 51. And then we've done a little algebra here. 100 of any sort of a thing minus 1 of the same thing is 99 of that same thing. Then 99 divided by 99 is 1x. But to keep this equation balanced, we do the same on the other side. And if we want to check this, it works. Again, I'm a big believer in explaining why, so notice that it's going 51, 0.51, 0.51, 0.51, 0.52. Now why is it doing that? Well, this decimal repeats infinitely. The calculator display does not. It's being rounded up. You may remember that if the next number is 5 or more, it rounds up. So what would really be a 1 in the expansion is getting rounded up to 2. Next, you can use the same technique to prove that 0.9 repeating equals 1. How? Just like before. Let x equal 0.9 repeating. Let 10x equal 9.9 repeating. And remember that this works because my bar here, as you may know, means that it's 9s all the way down. And if I move this decimal point over 1 in my notation, now this 9, the first one, is to the left of the decimal, but the rest are still there, and so it's still repeating after that. So 10x equals 9.9 repeating. Well, here we are. 10x is minus 1x is 9x. And in this case, the repeating parts cancel away, leaving 9 minus 0, which is 9. And what's the number that we can multiply anything by and hope to gain the same number with which we started? It's 1. And there you have it if you accept the other stuff I just showed you. This follows logically. 0.9 repeating is just another way to say it's 1. It's an unnecessarily awkward way, but these are the same number. Thank you for watching. Have some random marker tapping. Take care now.